Well, hello, everybody. Welcome to another program for Astronomy Days, right here at the North Carolina Museum of Natural Sciences. It's good to be back with you all again for another exciting program, or maybe this is your first program tuning in. It's going to be a great one. Glad that you're all here for this great day's worth of programs once again. I'll be your space host for this program. My name is Chris Smith here at the museum. And as we let everybody into the show and get settled and ready for another great program, I've got a question for you. You can see it on the screen. We're going to be talking a lot about asteroids in this one. So if you could name an asteroid you found and got to name one, what would you name it? Type up your answers in the chat on YouTube or in the chat if you're watching here on the Zoom call. I would love to see that, and we're going to come to your answers in just a moment. Now, if you're watching on YouTube, it's pretty simple. You've got the buttons there. You probably know how to use a YouTube. If you're joining me here on Zoom, I'll actually go through a quick tutorial just to make sure that you can all take advantage of Zoom's features and especially the accessibility features that are available to you today. So here on Zoom, of course, everybody is going to be muted and have their cameras turned off for the duration of the program. But just to be safe, down in the bottom left-hand corner, make sure that you have your audio and video turned off for us. If you would like to take advantage of the closed captions, we have live captioning available. Click the button at the bottom middle of the screen that says closed captions, and then you'll get a menu and you can click show subtitles. When you do that, you'll get some menu options where you can adjust the size of the text and how it looks to make it the best that you need, the best for you. Now, when we're getting to the program and we meet our guest speaker and they're sharing pictures and videos with us, we recommend that you click that button that says gallery view or speaker view up at the top right and make sure that it's set to speaker view. And then if you click the view options there towards the middle at the top, you can change it to side-by-side mode. Speaker view and side-by-side mode, we think, are the best way to take advantage of today's program. You can see the cool content and our cool guest speaker all in the same screen. Now, I do want you in the chat. If you've got questions at any point about anything in our program for our guest speaker, go ahead and type them up into the chat on YouTube and on Zoom. Our moderator is standing by to send those questions to me so that at the end of the program, we can ask your questions, right? Astronomy Days is interactive, so make sure that you're leaving thoughts and questions for our guest speaker as we go along. And that will be it. We're going to have a great show. I think so. Let me introduce today's guest speaker for this 12 o'clock program with Astronomy Days. Everybody say hello to Charvi Pandey. Charvi is a Lucy ambassador for LaSpace. We're going to learn more about what LaSpace is soon. Charvi is also a NASA Ames intern and a student at North Carolina State University in aerospace engineering and French. Everybody put your hands together and welcome Charvi to the program. Charvi, how are you doing today?
Hello, I'm doing great. I'm so excited to see everybody here. Today we're going to be talking about the Lucy mission. Before I dive right into that, we're going to get into some basic astronomy, just figure out why Lucy is going to study what she's going to study. Please be sure to ask your questions. I'm really intrigued. I want to hear them. And we can go ahead and get started. So on this title screen, you're going to see the Lucy spacecraft here. This is the artist's conception. You're also going to see an asteroid, a really, really big asteroid. And then in the back, you're going to see a little tiny Jupiter. And Lucy is going to be going near Jupiter to study some asteroids. And like I said, before we get into Lucy's fun stuff, we can go over some basic astronomy things. So when we think of the solar system, we generally think of the planets, Mercury, Venus, Earth, Mars. Maybe you're thinking of the gas giants, Jupiter, Uranus, Neptune. But in reality, our solar system looks a little bit like this. So there are all of these bodies in our solar system, these little dots that are asteroids, and they can range from the sizes of cars to the size of mountains. And a lot of these asteroids are made up of rock, and they are remnants of the early solar system. So we kind of consider them to be fossils. In this diagram, most of the little dots are asteroids. Some of them are comets. Some people like to draw the distinction between asteroids in like the Kuiper belt in our solar system and asteroids that are far beyond Neptune, so trans-Neptunian objects. But for our purposes, we're just going to consider all asteroids. So Lucy is a mission that is created by NASA, and Lucy is going to go study a never explored group of asteroids. And Lucy is named for a fossil that was found in Ethiopia. And the fossil was named Lucy, and she revolutionized the way that we think about how humans originated. And we're hoping that Lucy, the spacecraft, can revolutionize the way we think about the origins of our solar system. So these are the two groups of never before explored Trojan asteroids. They are beyond the main asteroid belt beyond Mars, and no spacecraft has ever visited them before. So why do I keep calling these asteroid fossils? Well, like I said, these asteroids have been around from the very, very beginning of our solar system. And when our solar system first started out, it kind of looked like this picture right here in the top right-hand corner. So it was this gaseous disk with a baby sun. This was about 4.5 billion years ago. And there was a lot of elements colliding with each other, and gravity helped it stick together, created asteroids, it created planets. Some planets got super duper big and they had enough gravity to attract a gaseous atmosphere that created our 4 giant planets. We had solar wind pushing a lot of the gaseous material towards the edge, which is why most of the gas giants are also at the edge of our solar system or towards the outer edge. And these asteroids that were present, these clumps of material that were present 4.5 billion years ago, some of them are still in our solar system today. So if we study these asteroids, potentially they can tell us what our early solar system looked like. So we can maybe figure out what sort of materials the rocky and the giant planets are made of. So the rocky terrestrial planets and then the gas giant planets. We can maybe figure out how the planets formed, if they moved around the solar system, and potentially also maybe how life made it here on Earth. It's possible that it was because of an asteroid carrying organic material. So there are lots of super duper interesting questions that Lucy can answer. One of the questions that I get a lot is, why not just study the planets themselves if we're trying to figure out, how planets were created and how the solar system formed? And that's a fair question. The problem is with a lot of these gas giants is that it's really hard to go underneath their gaseous atmospheres because there's a lot of pressure and there's a lot of heat. So it's not really feasible to send a spacecraft in there because it's not going to survive. But let's say we somehow have the technology to do that and we make it in there. By the time that we're seeing these materials that are inside of these gas giants, they have been altered by the heat and the pressure over millions and millions of years. So they're not really going to be the same as when they started out in the early solar system. But the asteroids are not altered by this heat and pressure, so they make the perfect group to study. So NASA is going on a road trip to a record-breaking number of asteroids. And by record-breaking, I mean 6. But this is still a really big deal because no single spacecraft has ever visited this many objects on their unique paths around the sun. So she is going to travel about 4 billion miles. And for context, this is like going around the Earth 160,000 times. So it's a really, really long trip. And in order to get to each of the asteroids she's going to visit, 6, she is going to need to go at a speed of about 40,000 miles per hour. And it's going to take her 12 years to go to these asteroids and study each of them. The actual data collection from these asteroids is going to take a couple hours, but getting, past Mars, past the Kuiper Belt, that's going to take a really long time. And one thing to note is that Lucy is not going to touch down on any of these asteroids. She's not going to be able to collect any samples from the asteroids. Instead, Lucy is going to do a flyby, which is super popular in a lot of spacecraft missions. Basically, she's going to use lots of really cool instruments and cameras to take pictures and collect data from each asteroid in about a couple hours. So super fun stuff. So she's going to be up there for 12 years. She's going to be going super duper fast. How is she going to do that? Because there's no pit stops in space. You can't stop and, gather fuel, and you're going to be a really, really long way from home. So that is why Lucy has these gigantic 2 solar arrays on either side of her. And you might have noticed this in the initial intro slide when there was an artist conception up. But these huge solar arrays are going to help power Lucy. She's going to take power from the sun, and that's how she's going to do her mission. Lucy actually breaks the record of the furthest from the sun a solar-powered spacecraft will go. And I think the previous record was held by Juno, which was another NASA spacecraft. So yeah, super cool stuff. So that makes Lucy about 50 feet wide from tip to tip. The actual spacecraft here, this middle part is not that big. It's about the size of a convertible car. I just would like to show pictures of these gorgeous solar arrays, though. This is at Lockheed Martin, where the final assembly took place. And here's another gorgeous photo. They kind of look like honeycombs to me. I think they're really pretty. And this right here are the solar arrays folded up. This triangle looking shape over here, and this is the Lucy spacecraft. And this is in launch configuration. So this is how Lucy was launched on the rocket. All right, so Lucy traveled to Cape Canaveral, Florida, for launch on October 16th. She launched at the first launch window opportunity, which is 5:34 a.m. Most spacecrafts, rocket launches, have launch windows, which days, weeks, months. And that's just in case, let's say like the weather's not great one day or something happens, we need to delay the launch. And it happens all the time. You can still get where you need to go as long as you're within the launch window. But Lucy launched right away as soon as the launch window opened. And I actually have video here of the launch. So if you looked it up, you could probably find news videos of Lucy launching, and it would be great quality. This launch video is from when I was at Cape Canaveral watching Lucy launch. So you're going to hear me yelling in the background, and it's exciting, I think. I think it's exciting to watch videos like this because it gives you a feel for the enthusiasm that people had while you were at launch. So if you just give me 1 second here, I'm going to stop sharing my screen so that I can pull it up. I recommend that if you have headphones on, that you turn them down just a little bit. All right, here we go. All right, can everybody see my screen? Is it all right? Maybe put in the chat. Okay, let's see. And can everybody hear this? Are we hearing it? Okay. So cool little video there. There was kind of a loud boom. I don't know if you could hear it, just happened in the video. But that was us hearing the engines. So super, super fun stuff. I'm going to go back to my lovely slideshow.
That was super cool. What was it like to be there?
Oh my God, it was amazing. Watching a rocket launch at night is so, and like being there in person is so different from watching it on TV. It's like the whole sky lights up. And also it was 5:30 in the morning and they wanted us there at about 2 a.m. So everyone was super, super sleep deprived, but it woke everybody up. It was super cool, super fun. If you ever get the chance to see a rocket launch, go see it. Super cool stuff. So anyways, now I want to kind of explore each of these asteroids in more detail. And right here, you're going to see our two principal investigators of the Lucy mission. They head the Lucy mission. So you have principal investigator Dr. Hal, and then you have Dr. Kathy, who is the deputy principal investigator, or deputy PI. All right. So, great. So Lucy, after she launched from Cape Canaveral, did a gravity assist. Basically, that means that she started out by flying around the Earth and using Earth's orbit to help gain speed and the energy that she needs to go all the way beyond Mars to the Trojan asteroids. One of the reasons that she did this was because Lucy was launched on a relatively small rocket. So in order to have the right trajectory, have enough energy, she needs to use Earth's gravity. And she will do 2 of these gravity assists. So she's going to do one, and then she's going to do a second one, and then she is going to head out to near Jupiter. Also, just wanted to make note, Lucy is not going to Jupiter. So she's studying the Trojan asteroids, which are by Jupiter, but she isn't actually going to Jupiter. The closest that she will be to Jupiter will be right before the first Earth flyby. All right, so after the second gravity assist where she goes around the Earth, she's going to head out to the Trojan asteroids, and she's going to go to the first group, which we call the Greek camp. So if you read the Iliad, the Trojans, the Trojan asteroids, Greek camp, Trojan camp, these are all terms from Homer's The Iliad, which is super, super cool to me. All right, so the first object that Lucy is going to study actually isn't a Trojan asteroid. It is a main belt asteroid. It's named after the discoverer of the Lucy the fossil, Donald Johanson. And this is kind of like a test run. It's kind of like a dress rehearsal for Lucy. She's going to make sure that her instruments are working, that she can collect data properly, just making sure that everything is going fine before she sets off for the Trojan asteroids. The asteroid itself is pretty interesting, though. It's relatively young, and some scientists think that it is about 130 million years old and that it's a fragment from a collision. And so it should be an interesting test run. And after this happens in 2025, she's going to go to the first Trojan asteroid, which is Eurybates, and this is going to be in 2027. So Eurybates is interesting because it's also a survivor of a collision, we think, and that collision probably brought a lot of materials that were deep inside the asteroid to the surface. And like I mentioned, we can't take samples of these asteroids. We're only doing flybys. So it's helpful that Eurybates brought all of this material to the surface, because if we study the surface of Eurybates, we're kind of studying what the inside of an asteroid might look like, or what deep inside an asteroid might look like. So that happens on August 12th. And then less than a month later, there's also Keda. So Keda is a small satellite of Eurybates. Keda is also a asteroid. And by satellite, I mean that it probably orbits Eurybates. You can see a picture of it here. This is from the Hubble Hubble telescope, and that little small green circle that keeps popping up, that is KS. So it's really, really, really tiny, like less than half of a mile wide. But less than a month later, we're going to go to the second target, which is the smallest Trojan asteroid that Lucy is going to study, Polymele. It's interesting to note. So this is September 15, 2027. As Lucy collects information about from the asteroids through the flyby, she's going to send this information back to Earth using a high gain antenna on her body, and we'll talk more about the instruments in a second. And that information is going to go to radio telescopes on Earth, the Deep Space Network, but it is going to take about a month for the information to travel from Lucy back to Earth. So by the time that Lucy gets to her second target, Polymele, the information that she collected from Eurybates won't even be back at Earth. So that's just something interesting. But after she goes to Polymele, she is going to go to Lucas, which is a strangely shaped Trojan asteroid. Lucas is kind of elongated and spins slowly, which means that probably something happened in the past to give it its interesting shape and spin. So Lucas should be an interesting one to study. And the next one is Orus. It's the reddest Trojan asteroid. A lot of outer solar system bodies tend to give off a reddish hue just because of organic molecules that are present on their surfaces. And we believe the same thing is true for Orus. And then after that, Lucy is actually going to come back and do another gravity assist around Earth. And this happens on Christmas Day, 9 years from now. And so this gravity assist, remember, gaining speed, energy, and also a trajectory or course adjustment so that she can head to her final 2 Trojan targets, which are Patroclus and Maimonides. And Patroclus is one of my favorite Trojan asteroids just because of its name. I really loved the myth of Achilles, and Patroclus is an important character in that. And all of these asteroids, as I mentioned, so Maimonides, Patroclus, Eurybates, these are all characters from the Iliad. And in the Iliad, you have a Trojan war going on between the Greeks and the Trojans. So all of these Trojan asteroids are sorted into groups. So there's one swarm and there's a second swarm. First swarm is the Greek camp, as we call them. Second swarm is Trojan camp, and all of the asteroids within the swarms are named after Trojan names or Greek names. Patroclus is an exception, however. Patroclus is Greek in the Iliad, but Patroclus is in the Trojan camp. So he's kind of like a spy. You can think of it like that. But these 2 are super interesting asteroids. They're in a binary pair, so they revolve around each other, and we get to visit 2 asteroids in a flyby time, whereas for each of the other ones, we would only see one. So a super duper cool way to end it off. And just because I kept mentioning them, I do want to briefly go over some of the instruments that are in that Lucy is carrying. So I did talk a little bit about the high gain antenna. That's going to help transmit data. We also have an assortment of cameras and spectrometers. So we have LaLaurie and LaRalph and LaTess, which are some cameras. We have T2 cam, which is actually going to help Lucy navigate. This L apostrophe is an indicator that these instruments are kind of remakes of instruments that have been used on other NASA or space missions. So, for example, LORRI, so not LaLaurie, but just LORRI, was used on the New Horizons spacecraft, and it took pictures of Pluto's moon Charon. And LaLaurie is basically the same instrument, but remade, and it's built for Lucy. So LaLaurie is a high-resolution black and white camera. It's going to give us a lot of information about the geological features of Trojan, so craters and other impacts like that. The next camera is the MVIC, which is part of LaRalph. LaRalph was Ralph was also part of the New Horizons mission. So the MVIC is a color camera. It's going to tell us what types of organic molecules these asteroids may carry. So there's MVIC on LaRalph, and then there is also LEISA. So LaRalph is basically made up of two instruments. There's a camera, and there's also an infrared spectrometer. And this infrared spectrometer is a crazy cool instrument that basically spreads out light and allows scientists to detect unique traces of ices that might be on the surface of some of these asteroids. There was a similar instrument, again, New Horizons mission, which detected ammonia ice in one of the craters of Pluto's moon. All right, and then there's also the TESS. The TESS is an infrared thermometer. It's going to measure the temperature of the Trojan asteroids. These asteroids mostly are getting their heat from the sun. So when we figure out their temperature, we might get an idea of how they are storing heat depending on how hot they are. So that was all the instruments. And you might have noticed throughout the presentation, I talked about the instruments, I talked about the big solar arrays that are used to power the spacecraft. That is all, that's engineers, but it's also scientists working together to drive the mission. So the scientists figured out, hey, we think we want to study the Trojan asteroids. We think that's going to tell us about the origins of our solar system. And the engineers were like, great, we're going to help build the things to get you there. And in addition to those scientists and engineers, we have project managers. You're going to have artists who are going to draw really cool pictures of mission conceptions. So a lot of people come together to make a space mission work, and it's years and years in the making. And I would just briefly like to share about L'Espace. If there's any college kids on here, or if you're thinking about going to college, this is a really great program for college students. It's basically like you take a semester's worth of learning how to do different things related to space missions. They have a mission concept academy. They have a proposal writing academy where you write proposals for NASA. I did both of these academies before I started my internship, and they were super cool. They basically reinforced that I wanted to go into space. I highly recommend that you apply if you have the time, or you pass this information on to any college kids that might be interested in space. That's a little detour there. After Lucy goes and studies all of these 6 Trojan asteroids, she's just going to keep going. So 12 years from now, probably around 2033, Lucy's mission is over, but her journey continues. So she's going to be in a relatively stable orbit. She's just going to keep going and going, doing a gravity assist around Earth. She's going to go back to Trojan asteroids. We might keep collecting data from her. We might try to visit some new Trojans. We haven't really, or the scientists and engineers haven't really decided yet. But we know for about another 100,000 years that she's not going to crash into Earth or anything remotely hospitable, and she's just going to keep going. So if hundreds and millions of years from now we're still here and we find Lucy again, we might bring her down, put her in a museum. If that doesn't happen millions of years from now, she's probably going to crash into the sun. But she would have done a great job studying these Trojan asteroids. I'm super sure of it. There's something really interesting about Lucy that I wanted to mention before I go, and that is the Lucy plaque. So there's another space mission which sent out a plaque on it, super famous. That plaque contained information about Earth, information about humans. It was meant for aliens, for extraterrestrials. This plaque, the plaque that goes on Lucy, it also contains things like in Nobel Peace Prize winners in literature. It has poems on it. It has important messages from humans, but it's meant for us. So it's meant for us finding Lucy after hundreds of millions of years, if she's, still going. And it's supposed to kind of carry a piece of us, and to explain to humans, why did we send Lucy up here, and why we wanted to explore the solar system, and just to wish them well. So I think that's a really beautiful sentiment. Over here, you're going to see Dr. Levinson, who was the PI of the principal investigator of the Lucy mission. And he's holding the plaque and gesturing to what is on it. And this on the right is someone at Lockheed Martin installing the plaque onto Lucy. So on that note, thank you so much for listening to me talk. I'm not sure if we have any questions.
Well, first, I'll invite everybody to give you another great big round of applause for delivering such a great presentation. People are remarking like your slideshow, just that looks great, and you did a fantastic job presenting. And we do have some questions. I do have some questions for you. And folks, I remind you, we've got lots of time left in our program, so that means we've got a lot of time to take your questions. Make sure that you drop them in the chat on Zoom or on YouTube, wherever you happen to be watching, and we'll go to your thoughts. So the first one that I've got for you comes from Jack, who wants to know, what's the difference between a satellite, as in an orbiting object, and a moon?
So moons are actually satellites. So a lot of the times when we refer to satellites, we say like, we're sending a satellite up. Those are man-made satellites. Satellites are anything that orbit other bodies. So the moon is orbiting us, so it's a natural satellite. If we build something and it goes up there and it's orbiting around Earth, that's a man-made satellite. So when I talked about CADA, let's see if I can go back to that slide. When I talked about, there she is. When I talked about CADA being a small satellite that was orbiting Eurybates, this was basically a really, really small asteroid that was orbiting another asteroid. So there really is no difference. A moon is a satellite. I hope that answered your question.
Yeah, sure did. Although there's a big, on my screen, there's a big square covering up the slideshow right now.
Oh, I'm so sorry. That's the chat screen. My bad.
Oh, yeah. Okay, let's see. So a question from Stephen about like Lucy's trajectory and the mission. So,
yeah.
So Lucy is going to be going to look at both groups of Trojan asteroids, like from the front and from the backside.
So Lucy is going to be by both groups. Did you mean like the Greek and Trojan camps? Is that what you mean?
I think so. Like I'm thinking of the animation you had at the end there. There was like two clusters.
Yes. So Lucy,
and there's all these like swings and gravity cysts to go back and forth between Earth and the next group.
Yes. Yeah. Exactly. So she will visit different asteroids in each of these swarms. So there's 6 in total. Some of them are from the Greek camp L4. Some of them are from Trojan L5. So yeah, she will visit both, and she will use 3 gravity assists in her time. 2 of them will happened right as she launches, and the third one will be after she visits about 4 of the asteroids. She's going to come back before she can go to the final 2, which are Patroclus and Meonidas.
Got you. Okay. Thank you. All right. Matthew wants to know, what do you do if the antenna falls off?
Oh my God. Well, I hope that doesn't happen. Yeah. If the antenna falls off, that would suck because we couldn't get all of the cool data that we are getting from these asteroids to Earth. However, I will say spacecraft craft systems are usually built with redundancy systems. Cry, someone said cry. Yes, exactly. So basically what that means is that they're going to have multiple systems so that if one thing fails, another thing can take over. And that's, people expect things to go wrong in space. So there most likely is a redundancy system in place so that, you know, if something really bad happens to the antenna, maybe another instrument can take over and keep sending whatever limited amount of data it's getting. But yeah, we're really hoping that does not happen.
And I guess it should be said too, like Lucy's already out there sailing on. And I think if something's going to happen to it, it's most likely to happen like at launch or as it's trying to deploy once it gets out into space.
Exactly.
Kind of like you talked about one of the solar panels not working quite right.
Yes. Actually, I don't even know if I mentioned that, but I do have a slide on it. Thank you so much for bringing that up. So,
okay.
Yeah, things do go wrong in space sometimes. So shortly after launch, one of Lucy's solar panels did not fully deploy. If you were following or if you knew about the mission beforehand, you might have seen it on the news. It didn't really create any problems for Lucy. She's still going on her trajectory. She's doing fine. She can still send back data. She has enough energy. Right now, scientists and engineers at NASA are trying to figure out, should we just let Lucy go like this because she can operate, she's fully functional, or should we try and possibly latch the array back? In either case, she's doing fine. You know, spacecraft it's safe, it's stable, it has a lot of power, and it's doing what it's supposed to do. So yeah, things go wrong in spacecraft missions all the time, but we've got super cool engineers and scientists who are working to fix those problems.
Good stuff. Okay, let's see. Next one on my list here. Are the Trojans more icy or stony, or we don't know, and Lucy will tell us?
So I will say that most asteroids are more rocky. Comets generally are the more icy substances. So comets most likely they're made out of ice, and they have, you know, regular orbits around the sun. However, as I mentioned, there is ice on some of these asteroids. So Lucy is going to help tell us how much of it there is and what it looks like, what it's made of, and all of that.
Excellent question. All right. Glenn writes, why is it going to take a month to get the data back? It's only a few light hours to Jupiter.
So true. Jupiter is kind of far away, but you're right. You know, why is it taking a whole month to get data back? And that is because of the systems that Lucy is using to communicate with the ground. So the Deep Space Network, which is on Earth, is a set of radio telescopes. They're looking at the sky, they're scanning the sky, and that is interacting with that antenna, that high gain antenna on Lucy. So when Lucy is sending information, that information is traveling all the way back to Earth, and then it's traveling to the Deep Space Network, and that Deep Space Network is interpreting this data and making it so that scientists and engineers can read it and understand it and possibly, you know, create or ask more questions based on it. So that is probably the reason why it's taking so long for this information to come back. So like if we have like a satellite and it's right above Earth, because we have a lot of satellites that are right above Earth that help us with streaming, like television. We have weather satellites up there. Those ones are almost instant, right? We have satellites that track fire management systems. So if there's like a fire somewhere, the satellite can detect that fire that's on Earth and alert authorities and be like, hey, there's a fire going on. And that thing takes like about a couple of minutes, but Lucy's really far away, and she's a pretty small spacecraft, so it's going to take her a bit to communicate with us.
All right, let's see here. And then Glenn with another one. Are the Jupiter Trojans located at Lagrange points?
Yes.
Are they hanging out in those stable gravity positions?
Yes, they are. That's a wonderful question. Yes, so Trojan asteroids, Jupiter is not the only planet that has Trojan asteroids. The term Trojan asteroids has come to mean any asteroids that hang out in Lagrange points of other planets. And if you don't know what a Lagrange point is, basically there are different points around bodies, planets, you can say, that have been theorized by a Italian-French mathematician named Lagrange, where if you put a body there, it's going to be stable enough that there's like a stable Lagrange points, L4 and L5, like I mentioned, and it's a stable place for a small body to be near a planet. So the way that they are divided up, the L4 and the L5 are stable points, and that is what we call our Greek camp, Trojan camp. That's a great question. I'm so glad you brought up Lagrange points. That's awesome. People were really fascinated when they discovered that Jupiter had Trojan asteroids that were in these stable Lagrange points, because in the past, the whole theory of Lagrange points was kind of just like a theory. So we hadn't actually been able to prove it. We just had the math showing that it probably should work. So when these Trojan asteroids were discovered by like a multitude of different people, we got really excited because that means they do exist. So great question.
Great stuff. All right. Kim asks, are there different types of satellites? If there are, what kind is Lucy?
Yeah, so there are different sort of satellites. So like I mentioned, you can have satellites that are just natural satellites, like the moon orbiting the Earth, or if you have a smaller body, smaller asteroid orbiting a bigger asteroid, that is also a natural satellite. I would call Lucy, I think Lucy, when I would refer to her, I would refer to her as a spacecraft and not a satellite. Just because mostly when we think of satellites, we think of it something just continuously orbiting around one other body. But yeah, there are different sorts of satellites. So, you can have man-made and natural, like I mentioned. And then sometimes you have two, like the two asteroids that I mentioned last. Let's see if I can find them. I think that was Patroclus and Meonides. Those two are a binary pair of asteroids. They revolve just around each other. You could consider them both satellites of each other. So I hope that answered your question.
I guess related, there are different kinds of spacecraft too. Like we can send telescopes and we can send just antenna, or spacecraft like Lucy that look in certain wavelengths of light, or carry particular scientific instruments. Like, I don't know, the sky seems to be the limit with the number of different kinds of technologies that we send up into space.
Yeah.
The sky's the limit. That's space. Anyway. All right, let's see here. Another one for you. Will communications be direct to Earth or relayed by other satellites?
Ooh, I think that it will be directly to the Deep Space Network, so directly to the radio telescopes that we have on Earth. Is what I believe.
All right, and let's see. Sean is asking why Lucy got that name, and we covered that right at the very beginning, but maybe quickly.
Yeah, so Lucy is named after a fossil, basically the remains of a really, really, really ancient human that some scientists found. And Lucy, the fossil, kind of changed the way that we think about how humans grew to be the way they are, you know, how we developed over time, how our species originated. So we're hoping that Lucy the spacecraft can kind of do the same sort of things, but more in terms of, you know, how the solar system formed and maybe how life got to Earth and fun stuff like that. And
all right, yeah. And go ahead.
Sorry. No, that's it. Sorry.
Is Lucy going to take like actual photos of the asteroids to send back, or is it just specific kinds of data?
No. Yeah. So she will take pictures of the asteroids to send back, which is going to be super exciting. She has a color camera and a black and white camera. The black and white camera will focus a lot on the geography. The color camera will try to tell us about what sort of like matter we can find on the asteroids, so like organic molecules we might find. So the two cameras were the MVIC, which is the color camera, and then the black and white camera, which was LaLaurie.
Okay, got you. All right, now another really good question for you here. Can you please, it's a little bit of a long one, bear with me. Can you please guide high schoolers how to follow this passion and get interested in space programs? What can they study? Or any advice that you have you could pass on?
Yeah, totally. If you're interested in space in whatever age, elementary, middle, high school, I think the best thing that you can do is just learn as much as possible. Take classes that interest you. As I said, you know, space missions, it's not just aerospace engineers and astronomers. You have project managers, you have artists, and you're going to have chemists, you're going to have physicists, geologists. So a bunch of different people study space, and they all have functions that are super important. So whatever part of space interests you, you know, take classes based on those. I took an astronomy class in high school. I had the best astronomy teacher ever, Mr. Basham. Get involved in robotics if that's what you want to do. You know, learn how robots move, learn how robots, you know, maybe we'll send robots up, or we do have robots up there. So just, you know, do things that interest you. And eventually when you get to college, then you can kind of choose a more specific topic. And at that point you can get involved in lots of cool things like internships and the LaSpace program, like I talked about. That's a great gateway to learning about space missions and getting more involved. And it's a really great step, I think, from transitioning from like high school to college and being a little bit more intentional and specific about what exactly you want to do in the space industry. But yeah.
That's a great answer. All right, a few more minutes here. And let's see. Let me see what questions we've got that are lined up here. So you showed us a picture of a cartoon of Lucy, showing us that the whole thing was about 50 feet wide end to end. The solar panels took up most of that, but how big is each one?
Ooh, good question. Let's go back. Maybe I have, let's see.
So I think compared to a lot of spacecraft that we've been launching, Lucy's kind of not one of the biggest.
No, yeah. So as I said, Lucy itself, the size of a car. So she's not as big as some of the telescopes and other spacecraft that have launched recently. So 50 feet tip from tip. I think the solar panels are going to be about 23 feet wide each. And probably, hold on, I think maybe I have notes somewhere. Yeah, so they're going to be 23 feet wide, and they're going to have a total area of about 51 meters squared. So they are really, really big compared to like the tiny actual spacecraft. And just for reference, there was a car.
So 23 feet wide solar panels, that's 4 Chris's stacked on top of each other.
Lots of Chris's.
Just okay. Let's see. Our moderator has dropped some links into the chat for the LaSpace program and information about Lucy on NASA's website. So folks, if you've got more questions and you didn't get them answered here, you can probably check out NASA or LaSpace and get those, find answers to those. let's see. Do you know who made those cameras?
It would most likely be, I couldn't give you a person, but it would most likely be the teams at Lockheed Martin or the Southwest Research Institute, which is where a lot of the assembly was done.
I think Marcel is just a Nikon fan and wants there to be Nikons in space. All right. Let's see. Well, you know what? Another good question just popped up here, and we've got a minute left. So does Lucy use rockets, or is it just the gravity assists?
So Lucy used a rocket to launch, but after that, she will not be using a rocket. So that is going to be, yes, gravity assists are going to help power her.
Good question. Good question. Both rockets and gravity. All right. Well, Charvi, thank you very much for being here.
Yeah, thank you for having me. This is super fun.
This was great. I love learning about Lucy. We were talking before the program that yesterday there was a program that was about lots of space missions that launched last year in 2021. And so we got heard about Lucy for like 2 minutes, and then we were on to the next mission. So this was a really fun, like, deep dive on this mission and learning more about what's out there in the solar system. So thanks very much. Everybody, I'll remind you that we've got a lot more Astronomy Days programs today, tomorrow, and Sunday, including a NASA astronaut tomorrow morning. So make sure that you visit naturalsciences.org/astrodays. Check out the remaining schedule of events, and I hope that I'll see you at more of our Zoom calls or tune in to our live streams right here on our YouTube channel. As we get ready to depart from this one, I want to thank our sponsors, the North Carolina Space Grant, Pepsi, and the Raleigh Astronomy Club for all of their help in bringing Astronomy Days to you. And you can continue to help us bring Astronomy Days to you by joining the museum and becoming a friend of the Museum of Natural Sciences, or doing something like cool, like getting one of these cool Astronomy Days t-shirts. The theme for Astronomy Days is Venus this year. And so, I mean, I don't know, it's kind of a cool shirt, right? It's kind of a neat shirt. So you can head to the museum store's website to pick one of those up. I think that's all that I have to say. Again, naturalsciences.org/astrodays for the schedule of events. And hey, everybody, we'll see you next time. Bye, folks.